Hi everyone. In this short video, I'm going to walk you through the very first R script we'll meet this semester, which is heights.R. The idea of this script is just to introduce you to a few of the very basic functionalities of R, things like calculating, creating variables, calculating means and standard deviations of data sets, that sort of thing. So I assume you've downloaded the heights.R dataset from the website, and now open RStudio, and to load it in, one simple way to do this is just to click Open File from the File menu, surf to wherever you've downloaded the heights.R script to, and open it up. I've already done that, so I hit Cancel. When you open up the script, you'll see a handful of panels that come up. This is the basic RStudio interface. Up here is the script itself, and this script contains various commands that you want to execute for this session. Easiest type of commands are simply those that treat R as a calculator. So, you can add 2 and 2, you can multiply 3 times 7, take the third power of 2, compute logs, exponentials, etc. Now, to execute each of these commands, you could simply type them directly into the console down here and hit Enter, and you would see the result pop up. But a simpler way, a way that I like to organize things, is to have a script that collects a group of related commands for a particular data analysis. So the way to get commands from a script, which I always put .r as the suffix for, is to get those commands from the script down to the console. Well, you could do the old-fashioned way and simply copy, Control-C, and paste Control-V down to the console, or you can source the commands directly by putting your cursor on the relevant line and hitting Command Enter if you're on a Mac or Control Enter if you're on a PC, and you'll notice that the command wherever your cursor sits, I'll move down here to line 8, wherever that cursor sits, that command will be executed down in the console. Okay, so that's a very, very simple way that R works as a calculator. Let's get into very simple data analysis here. Okay, so the first thing we need to do is to load the data set itself. And the way to do that in RStudio is to use this button over here in the Environment tab called Import Dataset. Pretty self-explanatory. So go ahead and click on Import Dataset, and then it should give you a couple of options. The one you want is from text file, because I assume you've downloaded the heights.csv dataset to your hard drive somewhere. So you open text file, and mine happens to be sitting in this directory right here, so I'll surf to wherever it lives, click on heights.csv, and click Open. And this little wizard should pop up, giving you various features of the data set. You want to make sure that everything is as you expect. So this is the raw input file up here, and you notice that the first line has the variable names. This is a data set on the heights of students in the first class I ever taught at UT, and the heights of their mothers and their fathers in inches. So that's the student height variable, that's the mother height variable, and that's the father height variable. And every row after that is a single case. So this particular student right here was 75 inches tall, his or her mother was 65 inches tall, and father was 71 inches tall. Okay, so you have to make sure that R recognizes there's a header row, and it's usually pretty good at detecting these things. It only makes a mistake on occasion. Here it says yes, it thinks there's a header row, and indeed there is, that header row being the row up here of variable names. What separates the fields? It's a comma, which is correct. R has auto-detected that correctly. And this down here is how R is parsing the data frame. So everything looks good here. We can just hit return. And now the data set should pop up. This is going to look like a spreadsheet. You can't edit it, but intuitively it's exactly the same thing as any Excel spreadsheet. The rows are the cases, and the columns are the variables. All right, so now that that data set is loaded, it's available for us to do stuff with. Let's go back to the heights.R script and start learning a few basic R commands. So very simple function here called summary. Heights right here now is the name of the data set that's been imported, and summary is a function. So this function takes a data set as an input and it returns a result. And in this case, if you put your cursor on line 15 and hit Command Enter or Control Enter, you'll notice that this summary function is giving you, as its name would suggest, a summary of each of the variables in the data set. And in this particular case, the summary that it gives you for each variable, it gives you the quartiles, so the first, the median, and the third quartile, the mean height in that particular variable, and the minimum and maximum values. And you get that all with just one command. Okay, so now let's learn how to compute a few basic summary statistics. The most obvious ones are the mean and the standard deviation. So let's say we wanted to compute the mean and standard deviation of the student height variable in this particular data set. Now, the structure of an R data set, there's the name of the data set itself, and then there's the name of the variables within the data set. So here the data set is called heights, and the variables are called SHGT, MHGT, and FHGT, all caps. R is case sensitive. And the way we reference a particular variable within a particular data set is using the $sign. So this bit right here says take the heights data set and the student height variable within that data set, and now we pass that to the function that computes the mean. So if we source this line down to the console, you'll notice we get the mean of this variable, student height, in this data set, heights$SHT. And we could have typed that directly down here if we wanted. And in fact, I'll do this with a different variable. Now we'll compute the FHGT, and it's a little bit different. Okay? All right, so that's for the mean. The next obvious quantity you would want to compute to summarize the data is the standard deviation. So that's the SD command. And now we have it. So if you wanted to summarize with just a couple of numbers the distribution of student heights in this sample, you would say the mean was 69.5, and the standard deviation is about 4, a little less than 4. All right, so those are some simple numerical summaries. Things get more interesting when we start making plots. So let's try histogram. So again, we use the same convention here, the dataset $variable name. So this says make a histogram of the student height variable within the heights dataset. And I'll just put my cursor on that line, hit Command Enter, and over here in the plots window, that histogram should plop up. And if you want to make this a little bit bigger, you click the zoom, and you should get a slightly bigger version that you can resize as you wish. Okay? So there's your histogram, and this is a more visual depiction of that distribution rather than just those two simple summary numbers. You can also do scatter plots. So let's say we wanted to characterize the relationship between the heights of students and the heights of their mothers. Well, the way we do that is with the plot command. Scatter plot would be an obvious kind of plot to make here. And this now brings us a new kind of formula here. So the way to read this line, so it's obviously going to call for a plot, and in particular, well, let's just source this, and it'll be easier to see. Over here, we get a scatter plot, and on the y-axis of this scatter plot, let me zoom in. On the y-axis of this scatter plot are the student heights. On the x-axis are the mother's heights, and every dot up here represents one particular row of the data set, and the position in this two-dimensional axis gives you the student height and the mother height for that person. Okay, so let's go back and look at this command so we can understand exactly what it's doing. This plot command says, all right, there's two variables we want to plot. This twiddle means modeled by or plotted by. So here, this is saying plot the student height variable against the mother height variable. So y-axis on x-axis, and we always think about the response being plotted against the predictor. Here, the student height is the response, the mother height is the predictor. And now you have to tell R where to find those variables. So these are variables, think of them as like columns in a spreadsheet. And where's the spreadsheet? Where's the data frame? Well, it's the heights. Okay, and if I omitted any of these, so for example, if I were to delete that and just say plot student height against mother height, I would get an error because R doesn't know where to find that variable. Okay, once I undo that, just hit Command Z there, I can do it and the plot comes back. All right. Just a few more things here. All right, so we computed the mean and the standard deviation of the student height variable, but one of the powerful things about R is that it allows you to store the results of computations in new variables and then use those intermediate values in subsequent computations. So let's see that in action. So before, we just said directly mean of student height here. Well, now I'm going to take the result of that computation and I'm going to store it in the variable mu. So the way to read this line is to say create a new variable called mu, and you could call it whatever you want, and inside that variable store the mean of student height. So when I source that line, you'll notice nothing happens down here in the console. There's no output. But now if I type mu into the console, now R knows what mu is. It stores the mean height of the students in this data set. And I can do the same thing for the standard deviation. I'll call that a variable sigma. Right? And as before, nothing happens, but sigma is there in the background ready to be used. Now we could use these variables in subsequent computation. So for example, if I wanted to take the center of the data set and go up 2 and down 2 standard deviations, I could create a new computation. Mu minus 2 times sigma is down to a little under 62. Mu plus 2 times sigma is up to about 77, and now that would be a decent way to describe an interval that covers 95% roughly of the cases in the dataset. All right, that's about the end of this one here. I just want to give you one quick pointer here, is that if you ever need to get help about any particular R command, you don't quite understand how it's behaving, you can use the question mark. So if you say question mark mean, it's going to come up over here as give you a documentation of that function and tell you what it does, how it behaves, what it expects as an input, and that sort of thing.